This is the solution to Spring 2018 problem number 12. So we've got a rod that's on a pivot right here connected to a wall. We've got a rope kind of wrapped around the rod and a mass. This angle is 45 degrees. And we are asked to solve for what this tension T is. So we start from the sum of the torques is equal to 0. And let's look at what our torques are. Well, we've got three forces on this rod. We've got the weight of the box, which is pulling down here. We've got the tension, which is pulling backwards. And then we've got the weight of the rod itself, which is being exerted at its center of mass halfway up the rod. And one of the nice things about the geometry of this problem is if this is 45 degrees, then this is 45 degrees, and this is 45 degrees. This is also 45 degrees. So when we write out the sum of the torque on the center of mass plus the torque from the block, which I'm calling M for mass, plus the torque of the tension is equal to 0. And then if I plug the numbers in for that, the torque of the center of mass is going to be the weight of the rod times L over 2 times sine of 45, plus the weight of the mass, the block, times L, it's at length, times sine 45. And then in the opposite direction, the torque is in the opposite direction from the tension, minus TL sine 45. And this is nice because all of the sine 45s cancel out and all the L's cancel out. And so I end up getting that WR plus over 2 plus WM minus T equals 0. So T equals WM plus WR over 2. I plug in the numbers. The mass of the block is 30 newtons. Mass of the rod is 20 newtons divided by 2, and I get 40 newtons, and the answer is B.